Hi, future teacher! Need a math refresher lesson to get prepared for your teacher certification exam? If so, you found the right spot. By the end of this lesson, you will be totally ready to tackle the geometry and measurement questions that you will likely receive on test day. But don't stop here. Get full access to the study guides, video lessons, and practice tests that makes passing your teacher certification exam simple by visiting teacherpreps.com.
In this video, we're going to talk about the characteristics of quadrilaterals. A quadrilateral is a type of polygon, and it's two-dimensional. What this means is that it only has a length and a width, and it's flat. A quadrilateral is also closed, meaning we don't have a shape like this, where there's an opening. We have straight edges and not curved edges, and then a quadrilateral means four. So a quadrilateral has four sides, 4 angles, and 4 vertices. Finally, the sum of the angles, or when you add all of the angles, you get 360 degrees. Let's talk about some of the common regular quadrilaterals. The first two regular quadrilaterals are squares and rectangles. On the left, we have a square, and on the right, we have a rectangle. What do you notice about both of these shapes? If you noticed that they both have right angles, you're correct. Both of them have 4 right angles. What else do you notice? Well, if you notice that on a square, all the sides are equal, and on a rectangle, only opposite sides are equal, you're correct. That's the main difference between a square and a rectangle. The final rule is that opposite sides are parallel, and that's true for both shapes. So the main difference between a square and a rectangle is that on a square, all the sides are equal, whereas on a rectangle, only opposite sides are equal. So a square actually fits the definition of a rectangle. However, a rectangle does not fit the definitions of a square. Let's move on to the next two regular quadrilaterals. The first is a rhombus. Rhombuses are also known as diamonds. And then on the right, we have a parallelogram. What do you notice about these two shapes? If you notice that they don't have the right angles like the square and the rectangle, you're correct. On a rhombus, though, just like a square, all 4 sides are equal. Whereas with the parallelogram, only opposite sides are equal. Now, neither one of them has right angles like the square and the rectangle, but the opposite angles are equal. That's also true on the parallelogram. The opposite angles equal each other. The final rule is that opposite sides are parallel. A rhombus fits the definition of a parallelogram, but a parallelogram does not fit the definition of a rhombus. To me, it almost looks like the parallelogram is a stretched out version of a rhombus. Let's talk about 2 more types of regular quadrilaterals. The first is a trapezoid. And then on the left, we have a kite. What do you notice about these 2 shapes that makes them different than the other ones? Neither of these shapes have right angles. Plus, the other ones' opposite sides were parallel and opposite angles were equal. Other than having 4 sides, trapezoids only have one rule. They only have one set of parallel sides. The rule for a kite is that adjacent pairs of sides are equal. If you notice, this blue side and this blue side are adjacent and they are equal. This red side and the other red side are adjacent and they are also equal. Now that we know the types of regular quadrilaterals, let's find missing angles in quadrilaterals. This question says to find the missing angle. So we're looking for this angle here. A quadrilateral has a total or a sum of 360 degrees. So we can say that 86 plus 90 plus 114 plus x, which is the one we don't know, equals 360. Now we have an equation we can solve. We need to first add 86, 90, and 114. When we add those, we get 290. We can rewrite the rest of the equation, and now all we have to do is to get x by itself. We do that by subtracting 290 from both sides. That leaves us with x on the left-hand side, and then 360 minus 290 gets us 70. So x must be 70 degrees. Go ahead and pause the video and try to find the missing angle of this quadrilateral on your own. Now let's see how you did. We're looking for this angle here. The sum of the angles is 360. So you can take 120 plus 95 plus 85 plus x and get a total of 360. First step is to add the angles that you already know. That gets us 300. So now we have 300 plus x equals 360. We need x by itself, so subtract 300 from both sides. That leaves us with x equals 60. So we know the missing angle is 60 degrees. In this video, we're going to talk about the characteristics of triangles. First, triangles are classified by their side lengths and by their angles. After we classify triangles, we're going to talk about the angles within the triangle. The sum of the angles in a triangle equal 180 degrees. What this means is that if you have two of the three angles, you can use this rule to find the missing angle. We can classify triangles by their side lengths. The first type is a scalene triangle. On a scalene triangle, all of the sides of the triangle are different lengths. Notice that this one has 3 notch marks, this one has 1 notch marks, and this one has 2 notch marks. Since none of them have the same pattern, this means that none of the sides are equal. Another type of triangle is an isosceles triangle. With an isosceles triangle, 2 of the sides are the same length. Notice that this side has 2 notch marks, and this side also has 2 notch marks. That means that those 2 sides are equal. The last kind of triangle that we can classify based off of the side lengths is an equilateral triangle. With an equilateral triangle, all the sides of the triangle are equal length. Notice that all 3 sides have 1 notch mark. That means all 3 sides are equal. We can also classify triangles by their angles. The first type of triangle is an acute triangle. With an acute triangle, all the angles of the triangle are less than 90 degrees. Notice that all 3 angles are less than 90 in this acute triangle. The next kind of triangle is a right triangle. With a right triangle, we have exactly one angle that measures 90 degrees. Notice that we have this little box here. When you see a little box on a shape, this means that it's a right angle, or it equals 90 degrees. The last kind of triangle is an obtuse triangle. With this, we have one angle that is greater than 90 degrees. In this triangle, we have an angle that is 110 degrees. So this is an obtuse triangle. Now let's use what we learned about the sides and angles to classify the following triangles. We need to classify them by both their angles and their sides. Go ahead and pause the video and classify these triangles. Now let's see how you did. Let's look at the triangle on the left first. When we classify the triangle by their angles, we see that we have one 90-degree angle, so this is a right triangle. When we look at their sides, we see that we have a side that's 3.2, a side that's 3.2, and a side that's 4.5. 2 of the sides are equal. That means it's isosceles. So we have a right isosceles triangle. Now let's move to the triangle on the right. This triangle has an angle that's 128 degrees, which means it's greater than 90, making it an obtuse triangle. Now let's look at their side lengths. Notice that none of the sides are equal. That means it's scalene. So the triangle on the right is obtuse and scalene. Now that we've learned how to classify triangles, we can talk about the angles inside the triangles. The sum of the angles in a triangle is 180 degrees. When we're trying to find a missing angle, we can use this rule to help us find it. We know that 90 plus 40 plus the x is going to get us 180 degrees. We can then add 40 and 90 to get 130 plus x equals 180. Finally, we can get x by itself by subtracting 130 from both sides. And we find that x equals 50. So x is 50 degrees. Go ahead and pause the video and find the variable x in this triangle. Now let's see how you did. We know that we can take 120 plus 20 plus x and get a total of 180 degrees. 120 plus 20 is 140. Then we can subtract 140 from both sides. That leaves us with x equals 40 degrees. So we know this angle must be 40 degrees. In this video, we're going to talk about the characteristics of three-dimensional shapes. A three-dimensional shape is a solid figure or shape. It pops out at you and has 3 dimensions. These are length, width, and height. Three-dimensional shapes have faces, edges, and vertices. Let's go through some of the regular three-dimensional shapes. The first 3D shapes that we're going to talk about are cubes and rectangular prisms. The shape on the left is a cube. The shape on the right is a rectangular prism. What do you notice the differences between the shape on the left and the shape on the right? If you noticed that there are 6 equal-sized squares for faces, you're correct. What do you notice with the faces of the rectangular prism? If you notice that instead of squares, all the faces are rectangles, you're correct. On a rectangular prism, opposite faces are equal, meaning the front and the back are going to be equal rectangles. Now, attributes include faces, edges, and vertices. We already talked about the faces. A cube and a rectangular prism both have 6 faces. Now, let's talk about the edges. The edges are these flat sides of each of the squares. So on this front alone, the cube has 4 edges. Pause the video and see if you can count how many edges the cube has. If you counted 12 edges, you're correct. Now pause the video and count how many edges a rectangular prism has. If you counted 12 edges on the rectangular prism, you're correct as well. The final attribute we're going to talk about is a vertice. A vertice is where the edges meet. On the front, there are 4 vertices on this cube. Pause the video and count how many vertices you see. If you saw 8 vertices, you're correct. Now pause the video and count how many you see on the rectangular prism. The rectangular prism also has 8. So the only real difference between a cube and a rectangular prism is that a cube has 6 faces that are equal-sized squares, where a rectangular prism has all faces being rectangles. Now let's talk about 2 more 3D shapes, cones and pyramids. On the left, we have a cone, and on the right, we have one kind of pyramid. What do you notice about the difference between these 2 shapes? If you notice that a cone has a circular base, you're correct. Now this pyramid has a square base, but a pyramid does not have to have a square base. It just has to have a polygon for a base. What this means is that we can have a square pyramid, a triangular pyramid, we can have a rectangular pyramid, and so forth. What's another difference that you notice? If you notice that the surface of the cone is curved, you're correct. The pyramid, on the other hand, has triangular faces. This is going to be true for every pyramid. And finally, if you notice that we have 1 vertice on each, you're correct. Both of these shapes come to a point. The next 3D shape that we're going to talk about is a cylinder. What do you notice about the cylinder? If you said we have 2 parallel and equal bases, you're correct. And they're both circles. We also have the curved surface that connects the 2 bases. In addition, there are no vertices on a cylinder. The last 3D shape we're going to talk about is a sphere. A sphere is a very interesting 3D shape. It doesn't have any bases. One interesting thing about a sphere is that it's completely symmetrical. No matter which way you look at it, all parts of the surface are going to be equal distances to the center of the circle. A sphere is round in shape. What this means is that we have no vertices, corners, or edges. In this video, we're going to construct geometric figures using a compass and a straight edge. The first thing we're going to do is start off simple by making a line segment bisector with the right angle. To bisect means to cut in half. We're going to start by making a line that is 6 centimeters long. Place the compass point at one end of our line segment. Then we're going to adjust the compass so that it's a little bit longer than half of the line segment. Next, we're going to draw arcs above and below the line. Then, we're going to place the point of the compass on the other side of the line and create arcs that overlap or cross with the other two arcs, one on the top and one on the bottom. Now we can draw a line segment going through where the two arcs cross. This creates that right angle. When we place the ruler back on the line, we see that our line segment is still 6 centimeters long. We wanted to bisect that, which means cut in half, which we did. 3 is half of 6. Now, let's construct a geometric shape by making a triangle that has the following side lengths. I'm going to start by drawing the side that is 4 centimeters long. We want to start by bringing the compass point to one end of that line segment. We want one side to be 3 centimeters long, so we're going to make it 3 centimeters long and lock our compass. Now rotate the compass and use the pencil to create an arc. Now unlock the compass and we need to make the third side, which is 5 centimeters long. Relock the compass and move the point so that it's at the other end of your line. The arc we just created is 3 centimeters away from the other end of our line. Now we're going to use the compass set to 5 centimeters and create the next arc. The distance from this end to where these two arcs intersect will be 5 centimeters long. Now we can use a ruler or a straight edge to connect one end of our line to where the arcs intersect, and then the other end of our line to where the arcs intersect. The length of the side on the bottom of the triangle was 4 centimeters, the longest side was 5 centimeters, and then the last side was 3 centimeters. A triangle that has side lengths of 3, 4, and 5 makes a right angle and is a Pythagorean triple. Next, let's create a square that has side lengths that are 4 centimeters long. I'm going to start by creating a line segment that's 4 centimeters long. In a different color, I'm going to extend that line out just a little bit. Our goal is to create a line that is perpendicular to the line segment that we made and directly above 4 centimeters. Move the compass so that the point is where the two lines meet. It doesn't really matter how long you have your compass set for, but it does matter that you have it locked. You want to create an arc, and then go to the other side of that point and create another arc. This point is exactly in between the two arcs that we just made. Also, remember our blue line is already 4 centimeters long. Now let's create the sides. Put the point of the compass on the arc you created on the left-hand side and extend the pen so that it's a little bit past that midpoint that we created. With the point of the compass in place, create an arc, move the point to the other side, and create another arc so that the two arcs intersect. Draw a line straight up going through where the two arcs intersect. This creates the side of our square. I drew it longer than 4 centimeters, but that's okay because we'll get the correct lengths later. Next, make the compass 4 centimeters long by using the original line segment that we made. With the point on the right-hand side, we're going to make an arc on the blue vertical line. This makes the side 4 centimeters long. Leaving the length of the compass the same, we're going to move it over to the left-hand side and create another arc. Now this distance that we just created is also 4 centimeters long. I'm going to create one final arc by taking the compass to the very top and rotating it around so that we create an arc that intersects with the top left arc. Where these two arcs intersect will be where the two sides of our square meet. The last step is to draw the sides of our square by going through our arcs. And now we have our square that has side lengths of 4 centimeters. In this video, we're going to draw conclusions based on the congruence, similarity, and lack thereof of figures. When you do these, it's important to know some key symbols. Perpendicular symbol looks like an upside down T. That means that two lines or line segments form a right angle. The symbol for parallel lines looks like an 11. That means that the two lines will never cross. And then congruent means the same or equal. So congruent symbol looks like an equal sign with a wavy sign above it. One term that helps us draw conclusions is the word bisect. To bisect something means that you're cutting it in half. Next, we have complementary angles. Complementary angles are two or more angles whose sum is 90 degrees. And then finally, we have supplementary angles. Supplementary angles are two or more angles whose sum is 180 degrees. Now let's use these terms and symbols to draw conclusions. This first question says, given that ABD is complementary to DBC, draw a conclusion about the figure below. The first question is what does it mean to be complementary? Well, to be complementary means that they form a right angle. What conclusion can you draw? Well, the conclusion that you can draw is that angle ABC is a right angle. That's because complementary means they form 90 degrees. So now the conclusion we can draw is that if two angles are complementary, then they form a right angle. We could also find this missing angle by taking 90 minus 37. That means the angle ABD is 53 degrees. Now go ahead and pause the video and try this one on your own. This question says that given line AB is perpendicular to line BC, draw a conclusion about angle ABC. The first thing is that we need to know that this symbol means perpendicular, and that perpendicular lines make 90 degrees. What you can say then is that angle ABC is a right angle. Now we can say that if two lines are perpendicular, then they form a right angle. Angle ABC will be 90 degrees. Let's go through this last problem together. It says that given that line AB bisects line segment GM, what can you conclude about line segment GB and line segment BM? Well, what does the word bisect mean? Bisect means that it's going to cut it in half, that we're going to have two equal sections. So you can conclude that line segment GB is going to be congruent to line segment BM. So we can say that if a line bisects a segment, then it divides that segment into two congruent or equal segments. In this video, we're going to identify different forms of symmetry. These include translations, rotations, and reflections. First, let's go through translations. In a translation, each point in a figure slides the same distance in the same direction. The way I remember it is that translation has an SL and slides has an SL. Usually you're given a direction, such as 2 places to the left. Let's go through a translation problem together. This says to translate the following triangle 2 units up and 3 units right. We're going to take each point and go up 2 units and then to the right. Let's start with the Y. We're going to go up 2 units and then to the right 3 units. Now we have our new position for our Y. When we plot the point, we're going to put this little dashed line in the right-hand corner. That means Y prime. Now we can do the same thing with point M. We're going to go up 2 units and then to the right 3. Notice that it landed on the same spot as G. That's okay. Now we have M prime. The last point to move is G, so we need to go up 2 and to the right 3. We can plot that as G prime. The final step is to connect our dots, and we can see the purple image is the translation of the green image. The next type of symmetry is called a rotation. A rotation is when an image is rotated around a central point. Notice that the S is rotated around the origin. it can be rotated a certain amount of degrees. In this case, it was 180 degrees. If it had rotated 90 degrees clockwise, it'd have been in quadrant 2, and if it had moved 90 degrees counterclockwise, it'd be in quadrant 4. A full rotation is 360 degrees. Again, a rotation can either be clockwise or it can be counterclockwise. Let's go through a rotation problem together. This says to rotate the following triangle 90 degrees counterclockwise around the origin. This means that we're going to go opposite of clockwise. We're going to rotate around the origin in the middle, and we're going to rotate 90 degrees. So we're going to go to the quadrant to the right. So to do this, it helps to count from the origin. Let's start with point B. Point B from the origin along the x-axis is 1, 2, 3, 4 units to the left. Then it's 1 unit up. We're going to follow that same pattern as we find B prime. So to rotate, instead of moving on the x-axis, we're going to go 4 units down on the y-axis. So we're going to go 4 units down and 1 unit left. This new point is B prime. Now let's move point X. Point X is 1, 2, 3 units along the x-axis, and then down 2. To find its new position, we're going to go down the y-axis, 3 units. We need to then go 2 units to the right, so we're the next quadrant over. And now we have X prime. The last point to rotate is point N. Point N is 1, 2, 3, 4, 5 units over on the x-axis, and then 1, 2, 3, 4 units down. So we're going to go 5 units down on the y-axis. We need to go to the right, and we need to go over 4 units. And now we have N prime. Lastly, connect the dots, and we have our rotated triangle. The last kind of symmetry is reflection. Reflection is also known as line symmetry or mirror symmetry. One half of the image is a mirror of the other. Look at the pictures below. On the butterfly, the left side is a mirror image of the right side, and the green T is a mirror image of the red T. The 2 lines of these images are mirrored over are called the lines of symmetry. Here's an example of a reflection problem. It says to reflect the following image over the y-axis. That's extremely important because that's what's going to tell us what to flip over. To find the new points, we're going to count how far away we are from the y-axis from each point. W is 2 units away from the y-axis. So we're going to move 2 units in the other direction on the other side of the y-axis. And now we have W prime. We're going to do the same thing with point S. Point S is 2 units away. So we're going to go 2 units on the other side of Y. And we have S prime. We're going to see how far P is, and P is 4 units away. So we're going to go 4 units on the other side of the y-axis, giving us P prime. And then finally we have I. I is 1, 2, 3, 4, 5 units away from the y-axis. So on the other side we're going to go 1, 2, 3, 4, 5 units away. And now we have I prime. We have our new image reflected over the y-axis. If we were going to fold this coordinate grid over the y-axis, the 2 images would land on each other. In this video, we're going to talk about the properties of parallel lines. These are parallel lines. Parallel lines will never cross each other. You can tell these are parallel lines because they're marked with these arrows. A line that cuts through 2 or more parallel lines is called a transversal. Knowing these relationships allows us to find missing angles within the parallel lines. Let's go through some of the relationships that are formed and talk about the different kinds of angles. The first is corresponding angles. These are angles that are in matching corners. And they're congruent, meaning they're equal. These are going to be on the same side as the transversal. An example would be this angle and this angle. If I made a cut and cut that out, picked it up and set it on top of this parallel line, those 2 angles would land on top of each other. They would match or correspond. Here's another example. They're on the same side as the transversal and they are matching. Another type of angle is a vertical angle. These are opposite of each other and it's when 2 lines cross. they're going to share the same vertex. These are also going to be congruent, which means equal. So we're looking at when the transversal and one of the parallel lines cross. They're going to share a vertex, and they're congruent. Let's talk about a few more types of angles that are formed when we have parallel lines. The next one is alternate interior angles. The word alternate means opposite, so we're talking about angles on the opposite side of this transversal. An interior means inside. So the angles are inside the parallel lines. These angles are equal. An example would be this angle and this angle. Another set would be this angle and this angle. The next is alternate exterior angles. These ones are also going to be opposite sides of the transversal, but instead of being inside like the interior, these are outside the parallel lines. These are also going to be congruent or equal. An example would be this angle and this angle. They're outside the parallel lines and opposite sides of the transversal. Another example would be this angle and this angle. The last kind of angle we're going to talk about is a consecutive interior angle. Consecutive means in a row, and interior means inside. These are non-adjacent interior angles, and they lie on the same side of the transversal. When we have consecutive interior angles, their sum is 180 degrees. An example would be this angle and this angle. If I added those two angles together, they would equal 180 degrees. Pause the video and see if you can name each type of angle and then find the missing angle. Now let's see how you did. On this first one, the two angles are on opposite sides of the transversal, but they are inside the parallel lines. So we have alternate interior angles. Alternate interior angles are congruent, so we know the missing angle is 111 degrees. Now let's look at the second one. They're on opposite sides of my transversal, but they're outside the parallel lines. So we have alternate exterior angles. Alternate exterior angles are congruent, so we know our missing angle is going to be 110 degrees. These last two angles are on the same side of the transversal, and if I pick this up and set it on top of the other one, they would match. So these are corresponding angles. Corresponding angles are equal, so x is going to equal 75 degrees. Sometimes we have to use algebra to find a missing angle. Let's first decide what kind of angles we have. If I pick this angle up and set it down on top of the other one, they would match, so we have corresponding angles. This means the two angles are congruent or equal. So to solve this, we can take 11x minus 2 and set it equal to 75. Now we can solve to find x. The first step is to add 2 to both sides. The negative 2 and plus 2 cancel, leaving us with 11x. And 75 plus 2 is 77. The last step is to divide out 11 from both sides. 77 divided by 11 is 7, so x equals 7. So using our angle relationships allowed us to find our variable. In this video, we're going to talk about proportional reasoning for scale drawings. First, let's talk about a scale factor. This is the ratio of the side length of a scale drawing to the corresponding side length of the actual object. A scale drawing is a drawing of an actual object that is either enlarged or reduced by a certain ratio or scale factor. To understand scale factors and scale drawings, we need to know what corresponding sides are. Corresponding sides are two sides that are in the same spot in two similar shapes. Let's go through finding scale factor first. On this question, it says that the following triangles are similar. What is the scale factor from the smaller triangle to the larger? We know that we're going to have an enlargement because our smaller triangle got bigger. The first step is to find your corresponding sides. One set of corresponding sides are 8 and 12. Those two sides match and are in the same spot on the similar shapes. Now that we have our corresponding parts, the next step is to put those corresponding parts in a ratio or a fraction. Now, since we're finding the ratio from the smaller to the larger, we know that we're going to have a ratio that is bigger than 1 because our triangle increased in size. So we need to put the corresponding side on the larger triangle in the numerator. That's 12. And then we're going to put the corresponding side of the smaller triangle in the denominator. That's 8. The next step is to simplify. We can divide a 4 out of both numbers. 12 divided by 4 is 3, and 8 divided by 4 is 2. 3 over 2 is an improper fraction. Let's make that a mixed number. That's 1.5. So the triangle's scale factor is 1.5. We could repeat this with two different corresponding sides, like 6 and 9. The 9 would go in the numerator and the 6 would go in the denominator. You can divide a 3 out of both 9 and 6, getting you 3 over 2. Notice that that matched? It would work the same with 10 and 15. Let's look at another example. This says that the following rectangles are similar. What is the scale factor from the larger rectangle to the smaller rectangle? So on this one, we're actually going to go opposite. Our rectangle is getting smaller. The first step is to find your corresponding sides. 45 corresponds with 9. Now, since we're finding the ratio from the larger rectangle to the smaller rectangle, we know that we're going to have a ratio that is less than 1 because our rectangle decreased in size. So on this one, we need to put the smaller rectangle side in the numerator. That'd be the 9. And then we need to put the 45 in the denominator. What can you divide out of 9 and 45? You can divide out a 9. That gets you 1 over 5. So in this case, our scale factor was 1/5. If you had chosen 20 and 4 as the corresponding sides, we would get the same ratio. 4 over 20 simplifies to 1/5. Now let's go through an example with a scale drawing. This one says that Sam has a toy race car that's a replica of his favorite sports car. The toy car is 3 centimeters wide. Use the scale factor to find the actual width. We know the scale is going to be 2 centimeters equals 6 feet. When you solve questions like this, the first step is to make the scale a ratio. So we have 2 centimeters over 6 feet. Now we're going to set up a proportion by matching up corresponding parts. Since we have centimeters in the numerator for our scale, we need to have centimeters in the numerator on the other side of our proportion. And we have feet in the denominator, so we need to have feet in the denominator on the other side as well. Now we can plug in what we know. We know that we have 3 centimeters, so that's going to go in the numerator. We're looking for the actual length, which will be in feet. The next step is to cross multiply. We know we have 6 times 3, and that's going to equal 2 times x. 6 times 3 is 18, and then we can divide by 2 to get x by itself. The actual width is 9 feet. In this video, we're going to talk about the Pythagorean theorem. The Pythagorean theorem was discovered over 2,000 years ago by a Greek philosopher named Pythagoras. The Pythagorean theorem is used to find the missing side of a right triangle. A right triangle means it is not acute or obtuse. It has one 90-degree angle. What Pythagoras discovered is that you can use the equation a squared plus b squared equals c squared to find the missing side of the right triangle. What you do is plug in the numbers you know and solve for the number you don't know. On the right triangle, we have A and B. These are called the legs, and they're attached to that right angle. We also have something called the hypotenuse. That's C. C is the angle directly across from the right angle. C is also the longest side. Let's go through a problem where we have to find the missing side using the Pythagorean theorem. On the triangle below, we have our right angle. So we know that we can use the Pythagorean theorem to find x. Now remember, our equation is a squared plus b squared equals c squared. A and b are the legs. They're the numbers that are attached to the right angle. So we know a and b are 12 and 5. It doesn't really matter which one we plug in for a and which one we plug in for b because we can add in any order. That means that we're missing c, which makes sense because c is the hypotenuse. It's the side that's across from the right angle. so x is really the c. So now that we know we're missing c, we can plug 12 and 5 in for a and b. Now we can start solving our equation. 12 squared is 12 times 12, which is 144. 5 squared is 5 times 5, which is 25. Now we can take and add 144 and 25. That gets us 169. So we have 169 equals c squared. We don't want to know what c squared equals, we want to know what c equals. You can eliminate the square by square rooting. But what you do to one side of the equal sign, you must do to the other to keep the balance. The square root and the square cancel, and we're left with the square root of 169. Now if you have a calculator, you can type this in, or you could see that 169 is a perfect square. 13 times 13 gets you 169. So c is equal to 13. That means the missing side of the triangle is 13 kilometers. Let's go through another example. This time, when we find our right angle, we see that we're given c. That's because it's across from the right angle. We're missing one of our legs, and we have the other leg. Recall that the equation is a squared plus b squared equals c squared. Since we know that c is 10, we can plug 10 in for c squared. And we're missing one of the legs. It doesn't matter which one you say is missing because we can add in any order. I'm going to say we're missing a. So we have a squared plus 6 squared equals 10 squared. Next, let's solve what we can. We can't solve anything with a squared, so we're just going to bring that down. 6 squared is 6 times 6, which is 36. And 10 squared is 10 times 10, which is 100. Now we have to get a by itself. To eliminate the plus 36, we can do the inverse operation of addition, which is subtraction. But what you do to one side, you must do to the other. That leaves us with a squared equals 64. Finally, we don't want a squared. We just want a. So we have to eliminate the square by square rooting. What you do to one side, you must do to the other. The square and the square root cancel, leaving us with the a, and the square root of 64 is 8, because 8 times 8 is 64. So the missing side length is 8 miles. Let's go through one final problem. This problem says that we need to decide if the triangle is a right triangle. Remember, the Pythagorean theorem only works for right triangles. If we plug numbers into the Pythagorean theorem and it works out, then we know we have a right triangle. The first thing we need to decide is which side is our c. C is the longest side, so we know we have 6, 8, and 9. 9 must be c because it's the longest. So we can plug 9 in for c. Then we're going to test out to see, is this a right angle? Plugging in 6 for A and 8 for B. Now let's test it out. 6 squared is 36, and 8 squared is 64. 9 squared is 81. Solve 36 plus 64. That gets us 100. Does 100 equal 81? It is not equal. Because our two sides are not equal, we do not have a right triangle. Had the two sides been equal, then it would have been a right triangle. In this video, we're going to represent three-dimensional objects through two-dimensional drawings. A three-dimensional object is a figure that has a length, a width, and a height. Many times, when we're finding things such as surface area of the three-dimensional shape, it helps to draw something called a net. A net is a two-dimensional or a flat image of the three-dimensional figure. Let's go through finding the net of several three-dimensional figures. We're going to start with a rectangular prism. In a rectangular prism, all of the faces are rectangles. Let's start with this one on the front. The rectangle on the front is long and skinny, so I'm going to draw a long and skinny rectangle. The long side of that rectangle is 6 inches, and the shorter side is 3 inches. Next, let's choose a one to the right of that long and skinny rectangle. That one's a little bit wider, so I'm going to draw a wider rectangle. The width is 5 inches instead of 3, but the height is still 6 inches. Now we have the rectangle in the back. That face is the same size and shape as the face in the front. So I'm going to draw another long and skinny rectangle. This one again has a height of 6 and a width of 3 inches. Then finally we have the one on the left. That face is the same size as the one directly across from it. It still has the height of 6 inches, but it has the width of 5 inches. Now that we've gone through all the faces, we can go through the bases. This shape has 2 bases, one on the bottom and one on the top. They're the same size and have the same height and width. So we can draw a rectangle on the top and a rectangle on the bottom. The length and width of that rectangle is 3 inches by 5 inches. And now we have our net. We have a 2-dimensional flat image of our 3-dimensional shape. Let's go through another figure. This one is a square pyramid. A square pyramid has a square for a base and triangular faces that come up to a point. Let's first start by drawing our base. Our base is a square. The sides of my square are all 5, because in a square, all sides are equal. Now we have our faces. Our faces are triangles, and because it's a square pyramid, all the triangles are going to be congruent. So you can draw a triangle coming off each of the sides of the square. The base of the triangle is the 5 inches because that's the side of the square. The height of the triangle is going to be 8 inches. Now we have our net of the square pyramid. Let's switch gears and talk about a cylinder. A cylinder is another type of 3-dimensional shape. It has 2 bases that are both circular, but instead of having flat faces, it has a rounded surface for a face. When I think of a cylinder, I think of a can such as a can of soup. The rounded surface is just like the label of the can. If you were going to cut the label of the can off, what shape would you get? If you thought rectangle, you're correct. The smooth surface of that cylinder makes a rectangle. But what's going to be the length and width of that rectangle? We have our 5. That's going to be the width. What do you think is going to be the length? The length is actually going to be the circumference of the circle. So that's a calculation you would have to find. Now all we have left are the 2 bases that are both circles. So we can draw a circle on the top and a circle on the bottom. The radius of the circle is 7 feet. And now we have the net of our cylinder. We have one final shape, and this is a cone. A cone has a circular base, just like the cylinder did. But unlike the cylinder, it only has one base. Our cone has a round, smooth surface, but because it only has one base, it comes to a point. When we draw our net, let's start with the circular base. On our circular base, we have the diameter given. It's 4 meters. Now we have to draw that smooth surface as a flat image. It's going to look very similar to what I just highlighted. But if you think about it, the smooth surface goes all the way around the circle. We can draw a curve that would be the same as the circumference of the circle. Then, since it comes to a point, we can draw those lines coming down. This is not the height of the cone though. These 2 sides are called the slant. And now we have the net of our cone. In this video, we're going to estimate and measure the area of 2-dimensional figures. Area is the amount of square units that fit inside a 2-dimensional figure. The equations that you use to find the area depend or change based on the figure that you're finding the area of. Let's first start with the triangle. This question says to estimate and to find the area. When you find area, you're finding how many square units fit in the inside of a figure. We can estimate by counting how many square units we see. I see 1, 2, 3, 4, 5, 6 whole squares. These 2 make 7, these 2 make about 8, and these 2 make about 9. So we can say the area is about 9 square units. Now let's find the actual area. The equation to find the area of a triangle is 1/2 base times height. Your base and height must make this right angle. The base and the height are the 2 sides that are connected to that right angle. Let's count the length of the base. It's 1, 2, 3, 4, 5, 6 units. And our height is 1, 2, 3 units. We can take 6 times 3 first. That's 18. Then we can take half of 18. That's 9. So the actual area is 9 square units. On this example, our actual and our estimation were the same. Let's go through another example together. This is a parallelogram, and we need to estimate and find the area of this parallelogram. Let's start with our estimation of our area. Remember, area is how many square units fit in the inside. So let's count how many whole square units we have. We have 1, 2, 3, 4, 5, 6, 7, 8 whole square units. This piece and this piece each look like half, so we can say that's about 1, making 9, and this piece and this piece look like they're about half, making another 1, so about 10. Using estimation, we can estimate that our area is about 10 units squared. Now let's find our actual. To find the actual, we need to take length times width. We know our length is along the bottom, and that's going to be equal to 1, 2, 3, 4, 5 units. Since our length and width have to make a right angle, we can make a right angle by going straight up from the length to the other side that is parallel. That red line is our width, and it's 1, 2 units long. So our area is going to be 5 times 2, or 10. So our actual area is 10 units squared. This matched our estimation of 10 units squared. Let's go through one final example together. This says to estimate and find the area of the following figure, which happens to be a circle. Let's start with our estimation. I count 1, 2, 3, 4 whole squares. We have several that are really close to being whole squares. Let's go ahead and round those up. So we can say this one, this one, this one, and this one are also close, making 8 squares. These two look like they might make a whole square, so that makes 9. These two look like they make a whole square, making 10. These two look like they make a whole square, making 11. And these two look like they make a whole square, making 12. So we can say that our area is about 12 square units. Now let's find our actual. To find the area of a circle, we take pi times the radius squared. In our equation, we have pi. Pi is an irrational number, and it goes on forever with no repeating. We can use the rounded version of pi, which is 3.14. The radius is the distance from the center of the circle to the outside edge. Our radius on this circle is 2. 2 times 2 is 4. So we have 3.14 times 4. 4 times 4 is 16. 4 times 1 is 4 plus 1 is 5. And 4 times 3 is 12. So our area is 12.56 units squared. Now this isn't exact because 3.14 isn't pi exactly, but it's a very close answer. So our estimation was 12 units squared, and our actual was 12.56 units squared. Our estimation and our actual were very close. In this video, we're going to estimate and measure perimeters of two-dimensional figures. The perimeter is the length around the outside of a figure. Let's go through this example below. It says to estimate and find the perimeter of the figure below. Well, to find the perimeter means to add all the sides. We need to estimate and find the actual perimeter. Let's first talk about estimation. Estimation means we're getting an answer that's close enough, and we may use rounding. Let's look at this first side. 7.9 is really close to 8, so we can round and say it's 8. 8.8 is really close to 9, so we can round and say that side is 9. 6.8 is close to 7, and 10.1 is close to 10. Now we can find the perimeter of the rounded sides. So we can say the perimeter is about 8 plus 9 plus 7 plus 10. To do some quick math, 8 plus 9 is 17, and 7 plus 10 is 17. So the perimeter is about 34 inches. To find the actual perimeter, we need to take 7.9 plus 8.8 plus 6.8 plus 10.1. Just as we did above, we can put together 7.9 and 8.8. That gets us 16.7. We can also put together 6.8 and 10.1. That gets us 16.9. We can add those two to get 7 plus 9, which is 16. 6 plus 6 plus 1 makes 13. And 1 plus 1 plus 1 is 3. And we can see our actual perimeter is 33.6 inches. Now let's compare our estimation to our actual. Our estimation was 34 inches, and our actual perimeter was 33.6 inches. They were very close. By finding the estimation, we can get a quick approximation, and we can also check to see if our actual perimeter is close to our estimation. Here's another example. It says to estimate and find the perimeter of the figure below, which means we're finding an estimation answer and the actual answer. I want you to pause the video, try it on your own, and when you're ready, hit play and we'll see how you did. Now let's see how you did. Let's first start with our estimation. We know that this side is 3.3, which is close to 3. Since these have the black marks, they're also close to 3. So we have 3 plus 3 plus 3. This side here is 1.9. That's very close to 2. And that equals this side on the other side. So that's also close to 2. Then we have 4.5 and 4.5. Both of those round up to 5. 3 plus 3 plus 3 is 9. Plus 2 is 11. Plus another 2 is 13. And then plus 10 is 23. So our perimeter is about 23 feet. Now let's find the actual. We have 3.3 3 times. So I'm going to take 3.3 times 3. That's 9.9. We also have 1.9 2 times, so I'm going to take 1.9 times 2. That's 3.8. That leaves us with our final two sides, which are both 4.5. So we can take 4.5 times 2. That gets us 9. When we add those, we get 22.7 feet. Now let's compare our estimation to our actual. Our estimation is very close to our actual. We have one final problem to go through, and this one says to just find the perimeter. Remember, perimeter means that you need to add all of the sides. Well, what do you notice about this figure? If you thought that we're missing this side, you're correct. We have our 4, we have our 5, and then we know this whole length of this side here is going to be 10. So how can we use the information given to find x? We can take 10 minus 3 to find x. We know x is 7 because since the whole length on the bottom is 10, we can take off the part of the triangle that's not on the rectangle above. Using this information, we can take 4 plus 7 plus 5 plus 10 to find the perimeter. 4 plus 7 is 11, 5 plus 10 is 15, and 11 plus 15 is 26. So we know our perimeter is 26 meters. In this video, we're going to calculate surface area. Surface area is the area of the outside faces of a three-dimensional figure. To help us, we make a net. A net is a two-dimensional or flat image of the three-dimensional figure. Let's go through this first example together. It says to calculate the surface area of the following figure. This is a rectangular prism. The first step is to draw our net of our rectangular prism. The first rectangle I see is at the very front. It's a little bit long and skinny, so I'm going to draw a long rectangular shape for the first part of my net. On the right side, I have this bigger rectangle. So I'm going to draw a bigger rectangle right next to the skinny rectangle. On the back side of my rectangular prism, I have a rectangle that matches the front rectangle. So I'm going to draw another long and skinny rectangle. And then on the left side, I have a rectangle that matches the one on the right. So I'm going to draw another bigger rectangle. Finally, I have the top and the bottom. So I can draw two rectangles, one on the top and one on the bottom. Now that I have my net drawn, I can go ahead and find the area of each piece. The heights on all of those rectangles in the middle are 6. On the skinny rectangle, my width was 3. And on the larger rectangle, my width was 5. On the two bases, which are the top and the bottom, I had one side that was 3 and the other side that was 5. When you're finding surface area, you're finding the area of each of the faces. So that's our next step, and you find area of a rectangle by taking length times width. 6 times 3 is 18. 6 times 5 is 30. We have another 6 times 3, which is 18, and another 6 times 5, which is 30. For my bases, I have 3 times 5, which is 15. The final step when finding surface area is to add all of the areas. So we can take 18 plus 18 plus 30 plus 30 plus 15 plus 15. 18 plus 18 is 36. 30 and 30 is 60. And 15 plus 15 is 30. Now add those numbers up. When we add all of our areas together, we get 126 inches squared as our surface area. Let's go through another example together. This is a square pyramid. The first step is to draw your net. We can start with the base. The base is a square. The side lengths are 5 and 5 since it's a square. Coming off the square are 4 equal triangles. So we can draw a triangle coming off of each of the sides of the square. The height of my triangle is 8. So now that we have our net, we can find the area of each of the shapes. First, let's start with the square. That'd be 5 times 5, which is 25. Then, we have each of the triangles. You find an area of a triangle by taking 1/2 times the base times the height. In this case, we have 1/2 times 5 times 8. 5 times 8 is 40, and half of that is 20. So the area of each of my triangles is 20. Now I can add all of my sides to find my surface area. The surface area is going to be 20 plus 20 plus 20 plus 20 plus 25. We have 20 4 times. 4 times 20 is 80. And 80 plus 25 is 105. So the surface area of my square pyramid is 105 square inches. We have one more shape to find the surface area of, and this is a cube. When we have a cube, we have 6 equal faces. So when I draw my net, I can draw 6 equal squares. The length and the width of each square is 12. So each area is going to be 144 square meters. Since I have 6 of them, I can really take 144 times 6 to find my total surface area. 6 times 4 is 24. 6 times 4 is 24 plus 2 is 26. And 6 times 1 is 6 plus 2 is 8. So my surface area is going to be 864 meters squared. There is a special equation that can be used for cubes. It's 6 times s squared. Think about it. The s was 12. So we have 6 times 12 times 12. That would have been 6 times 144, which is what we did. So for cubes, you could use this equation instead of drawing a net. In this video, we're going to find the volume of 3-dimensional figures. Volume is how many cubic units fit in the inside of a 3-dimensional shape. We're going to start by finding the volume of a rectangular prism. When you find the volume of a prism, the volume is capital B times H. Capital B is the area of the base, and H is the height. But recall, the volume is how many cubic units fit in the inside. So we're looking to see how many cubes fit inside this shape. The area of the base would be a rectangle. To find the area of that rectangle, we would take 5 times 2. That's our capital B. So capital B is going to be 10. For our height, we can count how many units up, which is 3. So our height is 3. So our total volume of this prism is 30 units cubed. That means you would fit 30 of those unit-by-unit cubes inside the figure. The equation for volume, which is capital B, or the area of the base, times h, or the height, is the same equation that you would use to find the volume of all prisms and cylinders. Here we have a triangular prism, so we could use this same equation to find the volume. You can find capital B, or the area of the base, of a triangle by taking 1/2 times the base times the height. So we can take 1/2 times 4 times 6. Half of 4 is 2, and 2 times 6 is 12. So the area of this base is 12. We can also see that the height is 5. So we can plug 5 in for the height. So to find the volume of this triangular prism, we can take 12 times 5, which is 60. So the volume of this triangular prism is 60 cubic millimeters. We can use the same equation to find the volume of the cylinder. We need to find the area of the base and times it by the height. The base is a circle. You find the area of a circle by taking pi times r squared. Pi is rounded to 3.14, and r on this one is the radius, or 7. So we need to take 3.14 times 7 squared, which is 49. Grab a calculator and type that in. That gets us 153.86. And remember, that's our capital B. So we can plug in 153.86 for our B. Our height on this shape is 5. So we can plug 5 in for the height. When you multiply 153.86 times 5, you get 769.3. So the volume of the cylinder is 769.3 cubic feet. Now the previous shapes were prisms and cylinders. This is a cone. To find the volume of a cone or a pyramid, the equation changes a little bit. Instead of taking capital B times h, we're going to take 1/3 times capital B times h. This is because 3 cones fit into its matching cylinder, just like 3 pyramids fit into its matching prism. So we're still going to find the area of the base. The area of this base is a circle, so we need to take pi times the radius squared. Pi is 3.14, and on this one they give us the diameter. We need half of that. Half of 4 is 2, so our radius is 2. We then need to take 3.14 times 4. That gets us 12.56. So in our equation, our capital B is 12.56. Then we need to times it by the height. Our height is 6. Grab a calculator and take 1/3 times 12.56 times 6. You could also take 12.56 times 6 and then divide by 3. You should have gotten 25.1 cubic meters. The last figure we're going to talk about is a sphere. The equation to find the volume of a sphere is completely different than the other 3D shapes. That's because a sphere doesn't have a base. To find the volume of a sphere, we're going to take 4/3 times pi times r cubed. Pi's rounded version is 3.14, and on this shape, our r is 4 because that's the radius. 4 times 4 times 4 is 64. Now grab a calculator and take 4/3 times 3.14 times 64. You could also take 4 times 3.14 times 64 and then divide that by 3. Rounding our answer, we should get about 267.9 cubic centimeters. In this video, we're going to look at the relationships and equivalent measurements within the metric and U.S. customary systems. First, let's talk about length. When we measure length, we are measuring how long something is, such as the distance from one location to another. We can measure the length using the U.S. customary system or the metric system. Pause the video and take a moment to look at the different measurements. Now, what did you notice? First, the base for length is meter. Next, the metric system works in powers of 10. For example, there's 10 milliliters in 1 centimeter. But then if we take 1 centimeter times 10, we have 10 centimeters that equals 1 decimeter. This makes it really easy to convert within the metric system. The customary system does not work in powers of 10. You need to know the conversion factors to move from one unit to the next. There are conversion factors to go from one system to the other. Some of them include 1 inch is equal to 2.54 centimeters, 1 yard is 0.914 meters, and 1 mile is 1.609 kilometers. Let's look at converting from the customary system to the metric system and vice versa. This first question says that you measure a pencil to be 4 inches. Estimate how many centimeters this would be. Notice the word estimation. An estimation answer means good enough. It doesn't need to be exact, it just needs to be an approximation. When I solve these, I like to set up proportions. The first step is to look at the conversion factor. We're going from inches to centimeters, so find the conversion factor that goes with inches and centimeters. That's 1 inch equals 2.54 centimeters. The first step is to write the conversion factor as a fraction. Notice that I put 2.5. That's because this question said that we could estimate, so I rounded 2.54 to 2.5. Now we have to set up the other side. Since inches is in the numerator on the left-hand side, it must be the numerator on the right-hand side of my proportion. Since centimeters is in the denominator on the left-hand side, it must be on the right-hand side as well. Now we can plug in what we know. We know 4 inches, and we're looking for how many centimeters that is. When you solve these, you can cross multiply. That means that we have 4 times 2.5 equals 1 times x, which is just x. So we need to take 4 times 2.5. That's 10. So we know a good estimation is about 10 centimeters. Now pause the video and try the second one on your own. When you solve this, you should have gotten about 3 yards. Now let's talk about weight. When we measure weight, we're talking about the heaviness of an object, such as the weight of a baby. Pause the video and take a moment to look at the different measurements. Now what did you notice? Well, just like length, the metric system works in powers of 10. The base, though, for weight is grams instead of meters. If you notice, the last part of each unit changed to grams. Just like with length, the customary system does not work in powers of 10. You have to know the conversion factors to go from one unit to the next. Now, to go from the customary system to the metric and vice versa, we have some conversion factors that help us go from one system to the next. 2 of the main conversions are 1 ounce equals 28.350 grams and 1 pound equals 454 grams. We have a question at the bottom. It says you have a ball that weighs 5 ounces and it wants us to estimate how many grams this would be. The key word there is estimation. So just as in the other problems, we can round our conversion factors. Go ahead and pause the video and try this one on your own. Now let's see how you did. The first step is to look and see what conversion factor we need. We have ounces and grams, so we can use the 1 ounce equals 28.350 grams. I'm not sure what you rounded to, but I'm going to round 28.350 grams to 30 grams. Now put the labels in the correct spot on the right-hand side. Now we have the 5 ounces, so I can plug that into the numerator, and we're looking for how many grams, so I'm going to put a variable there. Now we can cross multiply. We have 5 times 30 is going to equal 1 times x, which is just x. 5 times 30 is 150. So 5 ounces is about 150 grams. Now let's talk about the last measurement, volume. When you measure volume, you are measuring the capacity of something, such as how much water fills a tank. Pause the video and take a moment to look at the different measurements. If you notice that it still works in powers of 10 for volume in the metric system, you're correct. The base unit is liters. So just like in the other measurements, only the end of our units changed, and it changed to liters. In the customary system, it does not work in powers of 10, so you must know those conversion factors to go from one unit to another. Now to convert from customary system to the metric and vice versa, we have some common conversions that we can use. Take a moment to look at those conversions. The question at the bottom says that a glass of water has 8 fluid ounces in it. Estimate how many milliliters this would be. Again, the key word here is estimation. We don't need an exact answer, so we can round within our conversion factor. Go ahead and pause the video and try this one on your own. When you set up your proportion and solve, you should have gotten about 240 milliliters. In this video, we're going to use miles per hour to help us solve problems. Let's go through a few problems together. This first question says that it took a train 6 hours to go 240 miles. What was the train's average speed? What we're looking for is what was their miles per hour. When we set this problem up, notice that miles is first and hours is said second. To write miles per hour, we're going to make a fraction. Miles is said first, so we're going to put miles in the numerator. Hours is said second, so we're going to put hours in the denominator. Since we have the word per, we're really wanting to know how many miles you went in 1 hour. So we can set up a proportion to solve this. Corresponding parts need to match up, so 1 hour goes in the denominator, and we're looking for miles, so x can go in the numerator for miles. Now, how did you get from 6 to 1? You divide by 6. So since you divided by 6 in the denominator, you have to divide by 6 in the numerator. 240 divided by 6 is 40. So the train's average speed is 40 miles per hour. So when finding average speed, you can take the numerator divided by the denominator. Let's go through another question. This one's a little bit more challenging. It says that Tim drove to the mountains for a fly fishing trip. It took 4 hours and 30 minutes to drive to and from his destination. The distance to his destination is 117 miles. What was his average speed for the entire trip? Again, we're looking for miles per hour. So we need to have miles in the numerator and hours in the denominator. We see that we have 4 hours and 30 minutes. You cannot write this as 4.3. 30 minutes is half of an hour. You can write half as 0.5. So we need to put 4.5 in the denominator, because 4 hours and 30 minutes is 4.5 hours. Next, we need to put in the miles. They gave us what is to his destination, but we're wanting to and from. What that means is that he went 117 miles to, and then another 117 miles from. So we need to add 117 for the to 117 for the from. Tim went a total of 234 miles. To find the miles per hour, we want 1 hour. We can put an x in for miles, since that's what we're finding. To get from 4.5 to 1, we have to divide by 4.5. So we need to take 234 divided by 4.5. Go ahead and pause the video, grab a calculator, and take 234 divided by 4.5. You should have gotten 52. So the average speed was 52 miles per hour. We're going to go through one final problem. This says that Jessica can travel at an average speed of 60 miles per hour. At this rate, how many hours will it take her to go 150 miles? This question is a little bit different. This time, they give us the 60 miles per hour and want to know how long it will take for her to go 150 miles. To solve this, we can set up a proportion. We can set up 60 miles per hour as 60 miles in the numerator and 1 hour in the denominator. When we set this up, we need the corresponding parts to match. So since miles is in the numerator on the left-hand side, it needs to be in the numerator on the right-hand side. And hours is in the denominator on the left-hand side, so it needs to be in the denominator on the right-hand side. Now let's fill in what we know. We know that Jessica went 150 miles, so that can go in the numerator next to the miles. And we're looking for how many hours, so we don't know that. Next, we can cross multiply. 1 times 150 equals 60 times x. 1 times 150 is 150, and 60 times x is 60x. To get the x by itself, we can do the inverse operation of multiplication and divide. Lastly, we need to take 150 divided by 60. Go ahead and pause the video, grab a calculator, and take 150 divided by 60. You should have gotten 2.5. So it will take Jessica 2.5 hours to go 150 miles at that speed.